Hi everyone. Today we're going to look at finding the area of composite figures. And a composite figure is just that. It's a shape that's made up of other shapes. In order to find the area of composite figures, though, we need to review some of the formulas that you have worked with. One of the formulas we're going to review, which actually is the distance around the outside, would be perimeter. And again, when we find perimeter, we simply find the sum of the sides. So notice I don't have a diagram there. That's because my figure may have 5 sides, 10 sides, and I can't show all of the different variations. So with perimeter, we just say add all the sides together. When dealing with circles, we learned that to find the circumference, I can actually use two formulas. I can multiply diameter times pi, or 2 times the radius times pi. Now, remember that the diameter is the line that goes through the center, starts and stops on the circle. The radius is half the diameter, starts at the center and stops on the circle. Area is length times width, and again, just multiply the two sides. Area of a circle, radius squared times pi. Again, I need the radius. If I'm given the diameter, I have to divide by 2. And then to find the area of a triangle, base times height divided by 2. Now, remember with a triangle that your base and your height form a right angle. And so when you're looking at the triangle, you need to find that right angle in order to find the area. So now, let's look at the different types of composite shapes we're going to work with. The first thing we need to do is look at whether our composite shape is made up of more than one, or whether I'm actually just looking at the shaded region. So a composite figure is made up of 2 or more shapes. And to find the area, I'm going to break that figure into areas I know, and I'm going to add. So, let's look at some examples. First one, you'll notice, this is a rectangle, and that's a triangle. So I'm going to use those two formulas. But before I do, I'm going to just label the base of my triangle. And I know the base is 9 because that's a rectangle, and those sides are equal. Now, to find the area of my rectangle, 9 times 7, which is 63. To find the area of my triangle, 6 times 9 divided by 2, and that equals 27. So the area of the rectangle is 63, the area of the triangle is 27. Not finished, because now I need to add 63 and 27, and that gives me 90 meters square, the sum of those two shapes. Now, my second figure is a semicircle and a rectangle. So, in order to find the circle, I need to know the radius. Radius is half the diameter, so that means my radius is 2 yards. The dimensions of my rectangle are 4 and 2, so I'm going to find the rectangle by doing 4 times 2, and that equals 8. So my rectangle is 8. And then to find my circle, I need to do 2 squared times pi. Only I have to divide this by 2 because that circle is not a whole circle, it's a semicircle. So I need to divide. And then when I do 2 squared times pi divided by 2, my answer is 6.28. So now I have my semicircle and I have my rectangle. So I'm going to add 8 plus 6.28, and that will give me 14.28 yards squared for the total area. So again, it's just kind of breaking the shape into smaller shapes and then adding. Now, as you look at number 3, I have a square, and then that square is surrounded by 2 semicircles. I have to know that my radius is 5, and since I know that the radius is 5 and these two semicircles are equal, I can put them together and make a whole circle and just use that formula. So the formula to find the area of a square is 10 times 10, and 10 times 10 is 100, so the square is 100. And then to find the area of the circle, 5 squared times pi, and 5 squared times pi is going to give me 78.5. Now, you could break it down into two semicircles, and what you would do is then do 5 squared times pi divided by 2, 5 squared times pi divided by 2, and then you'd add it together. You're still going to get 78.5. Now what I need to do is just add my circle and my square. So 100 plus 78.5, 178.5 millimeters squared. Okay. Now, that's all I do when I have composite shapes that are put together. Now, the other type of shape that you're going to have to deal with is one in which you are asked to find the shaded region. Well, when I'm asked to find the shaded region, what I still have are 2 or 3 shapes, and I need to then kind of remove those shapes because I only want the shaded region. So when I work with figures in which I want the shaded region, I need to find the area of each figure, but this time I'm going to subtract. So let's look at number 4. Okay, I have a rectangle and I have a triangle. Now notice that the base of this triangle is missing, but I can figure it out because again this outer one is a rectangle, which means that these two sides have to equal. Well, that side is 13. I know that I have 4 on this side and 4 on that side, and that'll give me 8, which means that this base has to be 5 meters, because 4 plus 4 is 8 plus 5 is 13. I've got my height, and I know that that's 6. So I'm going to find first the larger rectangle, so that's going to be 8 times 13, and 8 times 13 is 104. So 104 is the entire rectangle with the triangle shaded in. Then I want to do 6 times 5 divided by 2, which will give me 15. That's the part I need to remove. So to find the area of this shaded region, I'm going to simply take 104 minus 15, and that will give me 89 meters squared. So we're sort of doing the opposite of those previous 3. Instead of adding it together, we're subtracting. Okay, number 5. Number 5, I have 2 rectangles. And this one's pretty straightforward. So my larger rectangle is 15 times 8. That will give me 120. My smaller rectangle is 3 times 5, and that will give me 15. And to find this shaded region then, I'm going to simply subtract. And when I subtract 120 and 15, I get 105, and again, feet squared. Okay, so I found the larger, took out the smaller. Okay, my last example. Last example is a circle inside a square, and again, I just want this shaded region. Now, when I look at this square, if I find the diameter is actually the same as the side length of the square. So if the radius is 2, that means that my diameter has got to be 4. And now, since the diameter is 4, that means the side of this square is 4. So find the area of the square. 4 times 4 is 16. Find the area of the circle. Now I need the radius. I just used the diameter to find the side. 2 squared times pi, and 2 squared times pi is 12.51. and I'm going to subtract those. Actually, it's 12.56. I'm going to subtract those, and when I subtract those, 3.44 inches squared. So again, I put together, I look at the shape, find the ones I know, add them. But when I'm looking for the shaded region, I'm going to do the opposite. Find the area, and then I'm going to subtract. Make sure that you fill in your Google Forms, and we'll talk about this tomorrow.